You are not a thing, you are a process. And that one sentence, which sounds like it should be mildly interesting and move on, is actually the beginning of one of the most destabilizing ideas that physics has ever quietly slipped into the conversation about what happens after you die. In 1907, a doctor tried to weigh the soul. He got a number. The number was wrong, but the question he was asking, where do you go when the body stops, turns out to be answerable. Not by religion, not by philosophy, by physics. And the answer involves quantum mechanics, the structure of space-time, and a theorem that proves you are, in the most rigorous mathematical sense, completely irreplaceable. Settle in, subscribe if you haven't, and stay to the end, because this one genuinely lands differently at the finish line. Let's ease into it. Part 1. The weight of a myth. There is a number that escaped from a poorly designed experiment in 1907, survived the death of the man who produced it, outlived the patients it was measured from, and is still circulating in your social media feed right now, and the number is 21 grams. Not 20, not 22, 21. Specific enough to feel like science, round enough to feel like fate, and wrong enough that if you showed the original data to any first-year statistics student today, they would hand it back to you with a polite but devastating look on their face. And yet here we are, more than a century later, still carrying that number around like it means something. That tells you more about human psychology than it tells you about the soul, and tonight we are going to find out what physics actually says instead, which is simultaneously more rigorous, more disturbing, and more philosophically destabilizing than anything Duncan McDougall ever put on a scale. But we have to start with him. We have to start in Haverhill, Massachusetts, in a hospital room that smells of carbolic acid and institutional linen, where a doctor with an interesting idea and a very large scale is watching a man die of tuberculosis and waiting. Duncan McDougall was not a fraud. That is the first thing worth saying. He was not inventing data in a back office or faking measurements for notoriety. He was a physician who genuinely believed that if the soul was a real physical entity, and in 1907 many educated people still believed it was, then it should have mass, and if it has mass, then the moment it departs the body should weigh less. That logic is not crazy. In fact, given what people understood about the physical world at the turn of the 20th century, it is almost reasonable. The crazy part is what happened to the data afterward. McDougall spent years designing his apparatus. He commissioned an industrial-scale bed scale, a platform balanced on a beam sensitive enough to detect changes as small as a few grams, while a full adult human body rested on it. He arranged with a tuberculosis sanatorium to have access to patients in their final hours, because tuberculosis, at that stage, produces a slow, predictable death, gradual respiratory failure, loss of consciousness, a body that stops fighting and simply runs down. That predictability was essential to his method. He needed to watch the numbers on the scale in the minutes before and the minutes after the moment of death, and tuberculosis gave him a long, readable approach to that moment. He collected 6 patients over a period of several years. 6. In modern clinical research, a sample of 6 would not even qualify as a pilot study. It would be a preliminary observation at best, a conversation starter at most, something you mention at a conference to see if anyone thinks it is worth pursuing further, not something you publish as evidence of the soul. But McDougall published, in 1907, in a journal called the Journal of the American Society for Psychical Research, which is itself a signal worth pausing on. This was not the New England Journal of Medicine. This was a publication specifically dedicated to the scientific investigation of psychic phenomena, which means the editorial standards were oriented toward taking claims like this seriously, rather than subjecting them to the kind of adversarial peer review that would have ended the story in the same year it began. The results, when you actually look at them, are a masterclass in the problem of motivated measurement. Of the 6 patients, only 1 produced a clean drop in mass at the moment of death, a drop McDougall estimated at approximately 21 grams, though his own notes record uncertainty about the exact figure. The remaining 5 patients showed results that ranged from ambiguous to actively contradictory. Some showed no change. Some showed changes at the wrong time. Some showed the scale moving in ways that McDougall himself acknowledged were difficult to interpret. In a properly controlled experiment, this scatter in the data would not produce a headline. It would produce a note in the methods section that said, "Results were inconclusive and further investigation is needed." Instead, McDougall picked the 1 patient whose numbers looked right and built his conclusion around that, which is a cognitive pattern so common in early scientific history and, let's be honest, in a lot of later scientific history too, that it has its own name. It is called cherry picking, and it is one of the most human things a researcher can do, because the brain desperately wants the data to confirm what it already suspects. He also ran the experiment on 15 dogs, because his theological model held that animals lacked souls, and therefore the dogs should show no weight change at death, which they did not. McDougall took this as confirmation. What he did not account for was that the dogs were almost certainly anesthetized to the point of death rather than dying naturally, which would alter the physiological processes dramatically, and also that the absence of a measurable change in 6 dogs versus 1 ambiguous positive result in 1 human patient is not a controlled comparison. It is 2 separate noise signals that he decided pointed in the same direction because he wanted them to, and then the number got out. The New York Times ran a story in March of 1907. The headline mentioned the weight of the soul. The number 21 grams embedded itself in popular consciousness with a kind of viral efficiency that we would recognize immediately today, but that must have seemed almost mysterious in the age before mass media. It spread through conversation, through newspapers, through the kind of cultural telephone game that transforms an uncertain measurement into an established fact within a generation. By the time scientists came around to properly debunking the methodology, the number had already become cultural mythology. The physicist R.I. Kennett published a critique almost immediately. Other physicians pointed out the confounding variables, the sudden cessation of evaporation from the lungs at death, the shifts in fluid distribution as circulation stops, the thermal changes as a body transitions from living to not living, all of which would produce exactly the kind of small, erratic mass changes McDougall was observing. None of these critiques moved the needle on public belief, because public belief was not tracking the scientific literature, it was tracking the story. And here is the question that actually matters, the one that is going to follow us for the rest of this video. Why does the story feel so much more true than the correction? Why does 21 grams persist in the imagination when the experiment that produced it was built on wishful thinking and insufficient data? Part of the answer is psychological. Humans are narrative animals, and a specific number attached to an ancient hope is a better story than a statistics lecture about sample size. But part of the answer is something more interesting. Part of the answer is that we have never quite resolved what we would accept as evidence either way. We carry the 21-gram myth, not because we have proven the soul exists, but because we have not yet fully confronted what physics actually says about what we are. And tonight is the night we do that confrontation properly, because physics does have an answer. It is not the answer McDougall was looking for. It is not the answer most religions offer. It is not even the answer most popular science communicators reach for when they talk about this topic. It is stranger and more precise than all of those, and it begins not with what leaves the body at death, but with what the body actually is to begin with, which turns out to be something far less stable, far less contained, and far less singular than you have probably been assuming your entire life. The first crack in the classical soul model is not the failure of McDougall's scale. The first crack is the realization that there was never a solid, singular thing on the scale to begin with, not because the soul is missing, but because even the body, the object that was supposed to contain the soul, is not the kind of object we thought it was. And once you understand that, the soul question transforms into something entirely different, something physics can actually speak to. So before we get to what leaves, we need to understand what was there. And what was there, it turns out, is not what you think. Part 2. The body is not a container. Consider this for a moment. The atoms in your body right now, the carbon in your cells, the calcium in your bones, the iron in your blood, the hydrogen that makes up more than half the atoms in every water molecule threading through your tissue, most of them were not in your body a year ago. They came from food, from water, from air, from the surface of every object you have touched and every person you have been close to. They cycled through the metabolic machinery of your cells, they did their structural and chemical work, and then they left. Through breath, through waste, through sweat, through the slow biochemical transactions that keep a living system running, and new atoms arrived to take their place. This is not a metaphor. This is isotope chemistry. Researchers who study biological turnover rates, and this has been done with remarkable precision using stable isotope labeling, where you can track the movement of specific atoms through living systems, have established that the vast majority of the atoms making up your body are exchanged with the environment over timescales of months to a couple of years. Your skeleton, which we tend to think of as the permanent, fixed infrastructure of the body, replaces its mineral content over the course of roughly a decade. Your soft tissue turns over much faster. The lining of your gut replaces itself every few days. Your skin sheds and regenerates continuously. Your red blood cells live for about 120 days and then are broken down and rebuilt. The number that gets quoted in this context, that about 98% of the atoms in your body are replaced within a year, has some nuance to it, depending on how you count and which tissues you are measuring. But the fundamental point is not in dispute. Your body is not a fixed collection of matter. It is a flow, a river that maintains its shape while the water composing it is constantly moving through. Take a moment to actually sit with that, because I think most people intellectually accept this fact and then immediately fail to feel the weight of it. You are not the same physical object you were 12 months ago. The hand you are using to hold your phone or your remote right now is built from atoms that, a year ago, were distributed across the food you ate, the water you drank, the air that passed through your lungs. Those atoms did not come labeled. They did not arrive carrying a flag that said previously assigned to a human. They were assembled from the raw chemistry of your diet, organized by the molecular machinery of your cells, put to work in the structures of your body, and eventually cycled back out into the world to be reassigned somewhere else entirely. Some of the carbon atoms that are currently part of your brain may have been, 2 years ago, part of a plant in another country. Some of the calcium in your bones was, not long ago, dissolved in groundwater. Some of the iron carrying oxygen through your bloodstream right now has been doing this kind of work in various organisms for hundreds of millions of years. You are, in the most literal atomic sense, a temporary arrangement, a pattern imposed on a stream of raw material that flows through you and moves on. This creates a problem that philosophers noticed long before physicists did, which is the problem usually called the ship of Theseus. The ancient Greeks told a story about a famous ship that was preserved in the harbour of Athens as a monument. Over the years, the wooden planks rotted and were replaced, one by one, until eventually no original plank remained. The question, is it still the same ship? Most people find this philosophically amusing but practically untroubling, because we feel intuitively that there is some kind of continuity, of form, of function, of identity that persists through the replacement of material components. We feel that the ship is still the ship of Theseus because it has maintained its structure, its purpose, its relationship to the city that built it. But what happens when you apply that intuition to your own body and then notice that the continuity is not being maintained by any fixed material component? The thing that makes you you, physically speaking, cannot be the atoms, they are gone. It cannot be the specific molecules, they are also gone, rebuilt from new atomic stock. It cannot be the cells, at least not most of them, because most of your cells have also been replaced. So what is it? What exactly is the continuous thread that makes the person reading this sentence the same person who woke up this morning, the same person who was a child, the same person who will, eventually, stop being a person? This is where physics starts to do something genuinely interesting to the soul question, because the answer that falls out of biology and chemistry and thermodynamics is that what persists is not a substance. What persists is a pattern, a configuration, an information state, a specific and extraordinarily complex arrangement of physical processes that maintains its organization not because it is made of permanent stuff, but because it is actively maintained by energy flowing through it. You are a thermodynamic process. That phrase sounds clinical. It sounds like the kind of thing you would say to deliberately remove the poetry from something beautiful. And I want to be clear that I am not trying to do that. I am trying to tell you something that is, once you really understand it, far more remarkable than any static description of what you are. A thermodynamic process is not a diminishment. It is a description of a system that takes in energy, dissipates energy, and in so doing maintains a structure of extraordinary complexity against the constant pressure of entropy, against the universal tendency of organized things to become disorganized. You are not a sculpture, you are a performance, and the performance has been running continuously, without interruption, since before you were born, organized first in the molecular machinery of your parents' cells, assembled into the pattern that became specifically you sometime in early development, and running continuously ever since. Your body radiates roughly 100 watts of thermal energy when you are sitting still. That is about the same as an old-fashioned incandescent light bulb. You, sitting quietly on your couch right now, are generating as much heat as a light bulb that was bright enough to read by. That heat is not waste in any simple sense. It is the exhaust of a metabolic process of staggering complexity. Billions of chemical reactions occurring simultaneously in every cell, converting the chemical energy stored in the food you ate into the mechanical work of your muscles, the electrical work of your neurons, the chemical work of building and maintaining your molecular structures, and yes, heat, always heat. Because no energy conversion is perfectly efficient, and the universe extracts its thermodynamic toll from every process that runs. And while that is happening, while you sit there radiating 100 watts of thermal energy and cycling atoms through the machinery of your cells, the universe is flowing through you in ways that would have seemed almost mystical to any physicist who lived before the 20th century. Neutrinos from the sun pass through your body at a rate of trillions per second. Trillions per second. These are subatomic particles produced in the nuclear fusion reactions at the core of the sun, and they interact so weakly with ordinary matter that your entire body, all the atoms, all the mass, all the biological complexity is effectively transparent to them. They do not notice you. They pass through the earth the way light passes through glass, and you are not even as much of an obstacle to them as glass is to light. They were moving through you last night while you slept. They are moving through you right now. They will continue moving through you until you stop being the kind of thing they can move through, at which point they will continue moving through the atoms of what remains, without noticing the difference, because to a neutrino, the distinction between a living person and a collection of dispersed atoms is not a distinction that registers. Cosmic microwave background radiation, the afterglow of the Big Bang, the oldest light in the universe, 13.8 billion years old, is everywhere, including the space your body currently occupies. It is not strong. It is extraordinarily faint, a thermal whisper at about 2.7 degrees above absolute zero, the universe's own background temperature. But it is there, in every cubic centimeter of space, including the cubic centimeters that your body fills. You are, at this moment, bathed in the oldest light in existence. It passes through you and continues on its way, carrying no record of the encounter. Quantum fields permeate all of space, including the space your body occupies. The electromagnetic field that mediates every chemical bond in your body, that holds your molecules together, that drives your neural signals, that organizes your biochemistry, extends throughout the universe. It does not stop at your skin, and the quantum vacuum, the seething, fluctuating energy state of empty space, underlies every cubic centimeter of the volume you occupy, populated by virtual particle pairs that flicker in and out of existence on timescales shorter than any process in your biology. What I am trying to get at with all of this is that the boundary between you and the rest of the universe is not a wall. It is a statistical gradient. It is a region where the concentration of a particular pattern, the pattern that is you, is high enough to be recognizable as an organism, and where that concentration falls off gradually as you move outward through your skin and into the surrounding air and beyond. There is no sharp line. There is no membrane that clearly separates inside from outside in any fundamental physical sense. There is a region of higher pattern concentration, and there is a region of lower pattern concentration, and the transition between them is the thing we call a body surface. Your skin is not a barrier, it is an interface. It is the place where the pattern that is you negotiates with the pattern that is everything else, exchanging matter in the form of shed cells and absorbed molecules, exchanging energy in the form of heat and light and chemical work, exchanging information in the form of every sensory signal that passes inward and every physical effect that passes outward. This negotiation never stops. It is continuous, dynamic, and bidirectional. And it is the negotiation itself, not the particular atoms involved, not the specific molecules, not even the specific cells, that constitutes you. Think about that in terms of identity. The thing that makes you specifically you, and not someone else, is not your atomic composition. That changes completely. It is not even your molecular composition. That changes too. It is the specific, extraordinarily precise pattern of organization that has been maintained through all of those material changes, the informational structure that persists through the physical flux, the way a river's character persists through the constant replacement of the water composing it. You are the pattern. You have always been the pattern. The atoms were always just visiting. When it stops, when the flow ceases, when the energy that maintains the organization is no longer available, when the biochemical machinery that runs the rebuilding process runs down, the pattern cannot maintain itself. Entropy, which has been held at bay by the continuous expenditure of metabolic energy, begins to win the argument it has been losing for your entire life. The highly organized structure begins to relax toward equilibrium. The atoms that were visiting do not disappear. They disperse back into the world, carrying no lasting mark of the organization they were temporarily part of, to be incorporated into other patterns in other contexts, as they have been incorporated into countless patterns before yours, and will be incorporated into countless patterns after. The brain adds another layer to all of this, and it is the layer that matters most when we are talking about the soul, because when people imagine the soul, the persistent, continuous self that carries identity forward through time, they almost always imagine it as residing primarily in the brain. The brain is, after all, the organ of thought and memory and personality, the seat of everything we call experience. If the soul is anywhere, surely it is there, and the brain does have one feature that seems to distinguish it from the rest of the body. Most neurons, the actual nerve cells, do not get replaced the way gut cells and skin cells do. Unlike the cells lining your intestine, which are replaced every few days, your neurons are mostly with you for life. They are formed in the extraordinary developmental explosion of early childhood and maintained, with some significant exceptions, until the very end. A neuron you have had since you were 3 years old is still there, still firing, still doing its work. For a moment, this seems like it might save the picture of a stable, continuous self. If the neurons persist, then surely the brain persists. And if the brain persists, then surely the self persists. But here is the thing. The persistence of the neuron cell bodies does not mean the brain is a stable, static structure. The synaptic connections between neurons, the junctions where one nerve cell communicates with another, which collectively encode something very like the wiring diagram of everything you know and feel and remember, are in constant flow. Synapses are strengthened and weakened through use, in a process called synaptic plasticity, that is the physical substrate of learning and memory. New synaptic connections are formed, old ones are pruned away. The molecular machinery at each synapse, the receptor proteins, the neurotransmitter molecules, the structural scaffolding that holds the whole architecture together, turns over continuously, even as the gross pattern of connectivity is maintained. The hardware stays, the wiring is constantly being rewritten, and your memories, the thing that feels most essentially like you, the accumulated record of everything you have experienced and understood and loved and lost, are not stored in your brain the way files are stored on a hard drive. This is one of the most unsettling things modern neuroscience has established, and it does not get nearly enough attention in popular science. Memory is not a fixed inscription in a fixed medium. Memory is a reconstruction. Every single time you recall something, your brain is actively reconstructing the experience from a distributed pattern of neural activity, pulling together fragments from different regions, assembling them into a coherent narrative, presenting that narrative to consciousness as a memory. And the act of reconstruction can modify the memory itself. The process of remembering rewrites what is remembered. The memory you have of a significant moment from your childhood, if you have one, is not a preserved recording of what actually happened. It is a probabilistic reconstruction built from pattern fragments that have themselves been modified by every subsequent experience you have had, every time you have recalled that memory before, every piece of information that has changed your understanding of the events involved. Psychologists have demonstrated, under controlled conditions, that it is possible to implant memories of events that never occurred, detailed, vivid, emotionally resonant memories that the person is completely convinced are real, precisely because memory is a reconstructive process that is vulnerable to subsequent suggestion and revision. Your most cherished memories are not archives. They are living reconstructions, actively maintained and continuously modified by the same system that generates them. What your brain actually is, at the deepest level of its function, is a prediction machine, a system that is continuously generating a model of the world based on accumulated experience, updating that model with every new input, and using that model to predict what will happen next. The experience of consciousness, the feeling of being you, the sense of a continuous observer moving through time is, in this framework, the output of that predictive process. It is what it feels like from the inside to be a model of the world that is modeling itself. What this means, in terms of the question we are working toward, is that there is no fixed location in your brain where you are stored. There is no neuron, no cluster of neurons, no physical structure that constitutes the self in the way a file constitutes its contents. The self is the process. The self is the ongoing activity of the system, the continuous dynamic of prediction and update and experience. And this matters enormously, because it means that when the activity stops, the self does not go somewhere else. There is nowhere else for it to go. The self was the activity. It was always only the activity. And the question of where it goes when the activity ends is like asking where the flame goes when you blow out a candle. The flame does not go anywhere. It ceases to be a flame. The wax is still there. The wick is still there. The carbon molecules that were oxidizing are still there, dispersed into the air around the wick, carrying the thermal energy that was released in the combustion. If you were sufficiently precise, you could track every atom. You could account for every quantum of energy. Everything that was in the flame is still in the room. Nothing has been destroyed. But the flame is not there. The integrated, self-sustaining, pattern-maintaining process that was the flame has ended, and no accounting of its former components, however complete, reconstitutes the flame. The flame was not the atoms. The flame was what the atoms were doing. And this is precisely where physics becomes both more and less comforting than you might want it to be. Because physics has something very specific to say about what happens to that information, to the specific pattern, the extraordinarily precise configuration of physical states when the process ends. And what it says is not nothing. It is not simple destruction. It is something weirder and more precise, and, depending on how you look at it, more disturbing than the idea that everything just disappears. Because what physics actually says is that the information does not disappear at all. It just becomes inaccessible in a way that is essentially indistinguishable from disappearance, while technically being something entirely different. And the distinction between those two things, inaccessible and gone, is where the strangest territory in this entire conversation lives. To understand why that distinction matters, and why it is, in the end, more philosophically confronting than the religious soul model for many people who think it through carefully, we need to go somewhere. Physics took a very long time to arrive at. We need to go to the place where information meets quantum mechanics. And once we get there, the question of what happens at death will never look quite the same way again. Part 3. Information does not die cleanly. In 2007, two physicists named Samuel Braunstein and Aaron Patty published a proof, not a hypothesis, not a model, not a well-reasoned conjecture that seemed probably right and was waiting for confirmation, a mathematical proof derived directly from the foundational equations of quantum mechanics of something that sounds almost too strange to be a physics result rather than a philosophical claim. They proved that quantum information cannot be hidden. Not just that it is difficult to hide, or that it tends to spread out over time, or that the technology to hide it does not yet exist, that it is impossible, in a mathematically rigorous and unambiguous sense, for quantum information to simply vanish from the universe. This result became known as the no-hiding theorem, and it was experimentally verified in 2011 using nuclear magnetic resonance techniques in a laboratory in India, which means it is not just a mathematical curiosity sitting in the abstract architecture of quantum theory. It is a demonstrated feature of physical reality. It has been tested, it holds, and the implications of it, when you chase them carefully into the territory we are exploring tonight, are simultaneously the most comforting and the most unsettling thing that physics has ever quietly placed on the table in a conversation about death. Let me explain what it actually means, because this is a place where the popular science version tends to either undersell the strangeness or oversell the comfort, and we are going to do neither. In quantum mechanics, any physical system, an atom, a molecule, a collection of particles, a human brain, exists in what is called a quantum state. The quantum state of a system is the complete physical description of that system, the most thorough account physics can give of what something is. It includes everything that can in principle be known about the system, the positions and momenta of its particles, their spin states, their energy levels, the correlations between them, all the physical properties that define the system and distinguish it from every other possible arrangement of matter. The quantum state is not just a list of properties. It is a mathematical object called a wave function, which encodes not just the definite values of observable quantities, but the probabilities of all possible outcomes if those quantities were measured. It is the full story of what a physical system is, in the most fundamental language physics has. Now, quantum systems do not stay isolated. They interact. When two quantum systems meet, when they collide, when they exchange energy, when one absorbs a photon emitted by the other, when they are brought into contact through any physical process, their quantum states become entangled. Entanglement is not a connection in the ordinary spatial sense. It is a correlation in quantum state space, a mathematical relationship between the descriptions of two systems, such that the state of one cannot be fully specified without reference to the state of the other. Once two systems are entangled, information about each is encoded partly in the other. The quantum information is distributed across the pair. This is the process by which information spreads through the physical world. Every interaction entangles. Every entanglement distributes information across the systems involved. And the no-hiding theorem establishes that in this process of distribution, the total quantum information is conserved. It cannot pile up in one place and nowhere else. It cannot disappear into nothing. If it leaves one system, it goes into the correlations with the systems that interacted with it. It is, in the language of the theorem, never hidden, never sequestered somewhere inaccessible where the rest of the universe cannot account for it. It is always, in a technically precise sense, somewhere. It is always in the structure of quantum correlations distributed through the physical world. Now apply this to a brain. Your brain, at any given moment, exists in an extraordinarily specific physical state, billions of neurons, each itself a system of extraordinary biochemical complexity, trillions of synaptic connections with specific conductances and receptor densities and neurotransmitter concentrations, a vast and constantly shifting pattern of electrochemical activity encoding your memories, your personality, your sense of who you are, your experience of this present moment. This entire physical configuration is, at the deepest level, a quantum state. It is built from atoms and molecules and electromagnetic fields, and all of those things obey quantum mechanics. The classical description we use for neural activity, the action potentials, the synaptic weights, the network connectivity patterns, is an approximation that works well at the scales neuroscience typically operates, but the underlying physics is quantum mechanical, all the way down. When you die, when the biochemical processes that maintain the specific organization of your brain state cease, that state does not simply vanish. It does not switch off the way a light switch cuts a circuit. What happens is that the physical system that was your brain, no longer actively maintained against entropy, begins to interact more extensively with its environment. The precisely controlled biochemical boundaries that kept the neural states organized start to dissolve. The molecular structures that encoded the synaptic weights begin to break down. The electrochemical gradients that generated the activity patterns dissipate. And as each of these processes occurs, the quantum information encoded in those structures entangles with the surrounding physical world, the air in the room, the molecules of the tissues around the brain, the thermal radiation the body emits, the gravitational and electromagnetic fields that the body influenced through its existence. The quantum information that constituted the specific physical configuration of your brain disperses outward in an expanding wave of quantum correlations, spreading into the environment in every direction simultaneously. The information, in a technically rigorous physical sense, is still there. Every quantum bit of it. The no-hiding theorem guarantees it. Your brain state, everything that made you you in the physical sense, the entire informational content of the pattern that was your mind, is conserved in the quantum information of the environment. It has not been destroyed. It has been redistributed. Now, here is where you have to be very careful. And here is where I want to slow down, because this is the exact point where popular science has a strong tendency to do something that sounds uplifting and is actually deeply, specifically, technically wrong. The tendency is to hear the phrase, "your information is conserved," and translate it, more or less automatically, into "you continue to exist in some form after death." And that translation is not just imprecise, it is wrong. It is precisely and specifically wrong in a way that matters enormously to the question we are asking, and we need to be very precise about why. The problem is something called the light cone. In special relativity, every event in space-time, every moment, at every location, has what is called a future light cone. The light cone is the region of space-time that the event can causally influence, determined by the speed of light. Since nothing can travel faster than light, the information produced by any event can only spread outward, at most at the speed of light, tracing a cone-shaped boundary through four-dimensional space-time. Everything inside the light cone is reachable. Everything outside it is not and cannot be by any process that respects the laws of physics. When your brain state decoheres at death and its information begins spreading into the environment, that information travels outward at speeds determined by the physical processes carrying it. Some of it moves slowly, molecular diffusion through biological tissue, the gradual thermal equalization of a cooling body. Some of it moves faster, acoustic vibrations, electromagnetic signals generated by the decaying electrochemical activity. And some of it, encoded in photons, in the thermal radiation your body has been emitting constantly throughout your life, and continues to emit after death, moves at the speed of light, the maximum speed that physics allows for the propagation of anything. And here is the horror. The specific, quiet, precise, physically rigorous horror that hides inside the apparent comfort of information conservation. That information, all of it, every quantum bit of what you were, is expanding away from its origin in all directions simultaneously, at speeds ranging from near zero to the speed of light, growing more diffuse with every passing moment, distributing itself across an ever-expanding volume of space, a volume whose surface area grows as the square of the time elapsed, a volume that, within microseconds of death, has already expanded to encompass the room, within seconds, the building, within minutes, the surrounding area, within a year, the light speed components of that information, the photons that carry the thermal signature of your final moments, have travelled nearly 6 trillion miles into space, in every direction at once, diluting and scattering and entangling with everything they encounter as they go. After 1,000 years, that information shell is 1,000 light years across. After 1 billion years, it has expanded across a sphere 1 billion light years in radius, centered on the coordinates in spacetime where you died. The information is in there, somewhere, encoded in the quantum correlations between particles distributed across a volume of space so vast that if you tried to imagine collecting it all, every photon, every entangled particle pair, every quantum of information that the decoherence process scattered, you would need to somehow access a region of the universe incomprehensibly larger than anything human civilization has ever surveyed. Moving backward through time against the direction of cosmic expansion, recovering correlations that have themselves become entangled with further correlations in a cascade of interactions that has been running since the moment of death. And even if you could somehow do that, which no physical process in this universe can, the original pattern would be so thoroughly scrambled into the background noise of the universe that recovering it would be, in any practical sense, not just difficult, but indistinguishable from impossible. This is not a technology problem. It is not a limitation that a sufficiently advanced civilization would eventually overcome. It is a fundamental feature of how information disperses in a universe that is expanding, that has a finite speed of light, and that has been running irreversible thermodynamic processes for 13.8 billion years. The universe does not erase your information. It just dilutes it forever into a volume no recovery process could ever span. The book is not burned. The book is taken apart, atom by atom, and each atom is mailed to a different address chosen at random from every address in the observable universe. The atoms still exist. The book does not. The physicist Stephen Hawking spent decades wrestling with a closely related version of this problem applied to black holes. When matter falls into a black hole, all the information about its specific quantum state, its composition, its history, the precise physical description of what it was, disappears behind the event horizon, inaccessible to the outside universe. Hawking initially argued that the information was simply destroyed, which would violate the no-hiding theorem and create a fundamental inconsistency in physics. The resolution that most physicists now accept, following work by Hawking himself in his later years and by researchers like Juan Maldacena and others working on quantum gravity, is that the information does eventually come back out, encoded in the Hawking radiation that a black hole slowly emits as it evaporates over astronomical timescales. The information is not destroyed, it is preserved, technically, in the radiation. But, and this is the crucial but, it is encoded in a form so scrambled, so thoroughly mixed into the thermal noise of the radiation emitted over the entire lifetime of the black hole, that it is operationally unrecoverable. To reconstruct the quantum state of a single particle that fell into a black hole from the Hawking radiation, you would need to measure essentially every photon the black hole has ever emitted with perfect precision and perform a computation of staggering complexity on the correlations between them. This is not physically impossible in the strictest sense. It is, for all practical purposes in this or any conceivable universe, the same as impossible. The information persists. The pattern does not. And the distinction between these two facts does not help the pattern. Think about that image for a moment, because it is worth holding. Take a book, a long one. Not just any book, but the longest and most complex and most personally meaningful book you can imagine. A book containing everything that has ever happened to you, every memory and feeling and relationship and hard-won understanding, every moment of love and grief and boredom and wonder, written in a language only you can fully read. Now burn it. Every carbon atom in the ash is still there. The molecules of carbon dioxide drifting through the air still exist. The heat released by the combustion has been absorbed by the surrounding air and the walls of the room, and the energy is still there, distributed into thermal motion. The water vapor in the smoke is still there. Physics guarantees, rigorously and completely, that none of the matter or energy has been destroyed. Not one atom is missing. Not one joule of energy has vanished. Everything that was in the book is accounted for. The no-hiding theorem is satisfied. Is the book still there? Is the story still there? Is there any meaningful sense, any sense that you, the person who wrote it or loved it, would recognize as meaningful, in which the novel survives in the smoke and the ash? You know the answer, and the answer is the same for you. This is what the no-hiding theorem actually offers. Not comfort, despite the way it sounds when you first encounter it. Not continuation. Not the preservation of anything you would recognize as yourself. It offers a technically precise statement that the information was not destroyed, wrapped inside a physically rigorous description of why that is completely irrelevant to the question of whether you, as an experienced, continuous, integrated self, continue to exist in any meaningful sense. The information and the self are not the same thing. The information is the raw material. The self was the specific, dynamic, coherent pattern that the information was running. Scatter the information across a light cone, expanding at the speed of light through an expanding universe, and you have not preserved the self. You have preserved the ingredients, in a form so dispersed that no recipe could ever reassemble them. You still exist, in the most literal quantum mechanical sense, and you are completely gone in every sense that matters to anyone who actually cares whether you exist. That is not a contradiction. That is what physics says. And the reason it lands so strangely, the reason it is more uncomfortable than the simple materialist answer, is that it is neither of the two clean frameworks most people reach for when they think about death. The simple materialist answer is something like, you are turned off like a light switch. The computation stops, the pattern dissolves, nothing persists, and that's the end of the story. That answer is at least clean. It is neat and final, and has the virtue of clarity. The physics answer is stranger, and, in a way, less forgiving, because it refuses to offer that finality. The data persists, forever, inaccessible. The pattern is gone, forever, irretrievably. These two facts coexist without resolving each other, without cancelling each other out, without adding up to either the comfort of continuation or the clean closure of simple termination. The universe conserves your information and loses you at the same time. And it does this without any awareness that there is a difference between those two outcomes. Because the universe does not have a perspective on what matters. The universe is honest, it is precise, and it is completely indifferent to whether its precision is kind. There is a study that gets brought up whenever this territory starts to approach clinical data, whenever the abstract physics conversation bumps up against the actual. Observed experience of people who have been as close to death as a human being can get and come back to describe it. The AWARE study, the name standing for awareness during resuscitation, was a multi-center investigation led by Dr. Sam Parnia, a critical care physician and researcher at NYU Langone Health, who has spent most of his professional career trying to apply rigorous scientific methodology to a subject that most of his colleagues would prefer to keep at arm's length. The study was published in its second phase, AWARE 2, in 2023, after nearly a decade of painstaking data collection across multiple hospitals and hundreds of cardiac arrest patients in the United States and the United Kingdom. The goal of the study was specific and carefully designed. Parnia and his team wanted to know whether cardiac arrest patients who reported near-death experiences, the well-documented phenomena of tunnels of light, feelings of peace, encounters with deceased relatives, out-of-body sensations, could recall specific, verifiable details about events that occurred in the room while they were clinically dead, while their hearts had stopped, while they showed no detectable brain activity by standard EEG measurements, while by every clinical definition available, they were not conscious and should not have been having any experience at all. This matters for our conversation not because near-death experiences, if genuine, would prove the existence of the soul as traditionally conceived. They would not, automatically, and we should be careful about that leap. But they sit exactly at the intersection of the question we are working through tonight, because they describe experiences occurring, or apparently occurring, in the period when the integrated pattern we have been calling the self should, according to the picture we have been building, be in the process of dissolving. If there is experience happening during that dissolution, that tells us something important about the relationship between brain activity, consciousness, and information, something that current neuroscience and current physics do not fully account for. The results of AWARE 2 were, and I want to be precise here because precision is the whole point, interesting without being decisive, deliberately and carefully and rigorously interesting. Some patients reported experiences of remarkable subjective clarity during their cardiac arrest, a sense of profound detachment from the body, of observing the resuscitation from a perspective somewhere above or removed from the physical scene, of moving through environments described as luminous or deeply peaceful, of encountering what they described as presences or beings. These experiences, on their own, are not scientifically remarkable in the sense of requiring an explanation outside normal neuroscience, because the dying brain is undergoing significant physiological changes: hypoxia, the release of various neurotransmitters, the shutdown of normal inhibitory processes, any of which could produce unusual subjective experience without invoking anything beyond biology. What is more interesting and more difficult to dismiss cleanly is a different category of report. A small number of patients in the study reported specific details about the events occurring in the room during their resuscitation, details about the actions of the medical team, about the equipment being used, about specific things that were said, that were subsequently corroborated by the medical staff. Not vague details, specific ones. The kind of details that a person lying unresponsive with a flat EEG should not have been able to observe. The study was careful and rigorously honest about its limitations, and those limitations are significant. The number of verified cases is small. The possibility of residual processing in brain regions not accessible to surface EEG electrodes cannot be ruled out. Memory confabulation, the brain's tendency to construct plausible narratives after the fact and experience them as memories, is a well-documented phenomenon that could account for at least some of the specific seeming reports. The study does not prove that consciousness persists after clinical death. It does not prove that there is any experience occurring in the absence of brain activity. What it does is raise a genuine and methodologically serious question about where exactly in the dying process conscious experience ends, and whether the measurement tools currently available are sensitive enough to detect that endpoint with the precision we tend to assume they have. And that question matters for our purposes because it shifts the frame slightly. If the endpoint of conscious experience is not the moment of clinical death, but some point after it, some point further along the process of neural dissolution, then the quantum information encoded in the last experiences of consciousness disperses later than the simple clinical picture would suggest. Not differently, not to a different destination, not into anything that the no-hiding theorem treats as an exception, but later, from a state that is, perhaps, more organized, more coherent, more experientially rich at the moment of its dispersal than the picture of instantaneous switch-off implies. Whether that matters philosophically, whether it changes anything about the fundamental question of what is lost when the pattern dissolves, is something we will return to. But it is worth holding on to the finding, because it is one of the few places in this conversation where clinical data touches the abstract physics, and the contact point is genuinely interesting. What it does not change is the dispersal. Whether consciousness ends at the first flat line or at some later threshold, whether the last signal fires at minute 1 or minute 20 of the resuscitation attempt, the no-hiding theorem does not grant exceptions. The light cone expands regardless of when exactly the final coherent state is reached. The information disperses at the same speeds determined by the same physical laws. And the scrambling into the background of an expanding universe proceeds with the same indifference to the richness or the poverty of what was lost. A mind full of love and memory and 50 years of accumulated understanding disperses exactly the same way as a mind that was barely formed. The universe does not grade on a curve. It does not distinguish between the complexity of what it scatters. This is, I think, the point where the physics stops feeling abstract and starts feeling personal. Because at some level, you have been following this argument from the outside, thinking about the soul in the third person, about what happens to human consciousness in general. And now I am asking you to think about your own specific quantum state. The specific, extraordinarily complex, absolutely unique physical configuration that is you right now, reading or listening to this. The synaptic weights encoding your particular memories. The electrochemical patterns that constitute your personality and your preferences and your sense of humor and the things that have hurt you and the things that have made you glad. all of it a quantum state, all of it subject to the no-hiding theorem, all of it destined, at some point that you do not know and cannot know, to decohere into the environment and begin its one-way expansion outward at the speed of light. And the fact that it will never be destroyed, the fact that the no-hiding theorem guarantees its conservation, offers precisely as much comfort as knowing that every word of a burned book is accounted for in the ash. The universe is honest, it is precise, and the honest, precise thing it is telling us is this: information conservation is not self-preservation. The data and the pattern are not the same thing, and the laws of physics, which are the most reliable things we know about how reality works, were not designed with the distinction in mind, because the laws of physics were not designed by anything, and the universe has never once shown any interest in whether its rules are bearable. But whether consciousness ends at the first flat line or at some later threshold, the no-hiding theorem is unchanged. The dispersal is the same. And the question of whether that dispersal constitutes any form of continuation, whether the scattering of information into an expanding light cone is a kind of existence, a kind of afterlife, in any technically defensible sense, leads us necessarily to the next constraint that physics places on the soul question. A constraint that is, in some ways, even more fundamental than information conservation, because it does not address where the information goes after death. It addresses something more basic, what it means that there was only ever exactly one version of it to begin with. Part 4. The self cannot be copied. In 1982, two physicists, William Wouters and Wojciech Zurek, published a result that sounds, when you first encounter it, like it should belong primarily to the world of engineering, like it should be a technical constraint that matters to people building quantum computers and quantum communication networks, not to people lying awake at night thinking about what happens after they die. It turns out to be one of the most philosophically significant results in the history of physics, and almost nobody outside the field knows it exists. They proved, from the mathematical structure of quantum mechanics, that an unknown quantum state cannot be perfectly copied. Not that it is difficult to copy, not that the technology does not yet exist to copy it, not that copying it requires more precision than current instruments can achieve, that it is physically impossible, in a mathematically rigorous and absolute sense, to create a perfect duplicate of an unknown quantum state. This result is called the no-cloning theorem, and it is not a limitation that a more advanced civilization will eventually engineer around. It is a mathematical consequence of the linearity of quantum state evolution, a fundamental structural feature of the theory that governs the behavior of every particle in the universe. You cannot get around it by building better equipment. You cannot get around it by developing smarter algorithms. It is not a wall that technology will eventually climb. It is a wall that is made of mathematics, which is a different kind of wall entirely. Here is the intuition behind why it is true, because the proof is elegant and worth understanding, at least in outline. In quantum mechanics, measuring a quantum state disturbs it. This is not a statement about the clumsiness of our instruments. It is a fundamental feature of the theory. The act of acquiring information about a quantum system necessarily affects the system being measured, in ways that cannot be avoided or corrected after the fact. The properties of a quantum system do not all have definite values simultaneously in the way the properties of a classical object do. A quantum particle does not have a definite position and a definite momentum at the same time. It exists in a superposition, a mathematical combination of all possible values, and the act of measurement causes that superposition to resolve into a specific outcome at the cost of introducing irreducible uncertainty into the conjugate property. This is Heisenberg's uncertainty principle, and it is not about measurement error. It is about the structure of physical reality at the quantum scale. Now, to copy a quantum state perfectly, you would need to know exactly what it is. You would need a complete description of the state, all its properties, all their values, the precise mathematical object that represents it. But obtaining that complete description requires measuring all the properties simultaneously, which quantum mechanics forbids. You cannot perform the measurement without disturbing what you are measuring. And you cannot copy what you cannot fully characterize without alteration. The information is there, in the quantum state. It is physically encoded in the system. But it is encoded in a way that does not permit the kind of passive, non-invasive readout that copying requires. The moment you try to extract enough information to make a copy, you have changed the original. The copy you produce is, at best, an approximation, and approximations, in quantum mechanics, are not copies. They are different states. There is a process in quantum mechanics called quantum teleportation, which can move a quantum state from one location to another with perfect fidelity. But quantum teleportation is not the counterexample it might seem to be, because the process requires the destruction of the original state at the source. The information moves. It does not multiply. You end up with one copy at the destination and no copy at the origin. Quantum teleportation is not duplication. It is relocation. And relocation, we will see, has its own profound implications for the question of identity. So, what does any of this have to do with the soul and with what happens after death? Let us follow the thread. Consider what is currently the most scientifically and technologically serious proposed solution to the problem of death in the futurist and technology community. Mind uploading, sometimes called whole brain emulation, is the idea that the brain could be scanned at sufficient resolution to capture its complete connectome, the full wiring diagram of all its neural connections, with the synaptic weights, the receptor densities, the complete structural and functional map of the neural network that generates consciousness. That information could then be implemented on a different computational substrate, silicon, or some future material, and run as a simulation. The consciousness encoded in that simulation would, in this scenario, continue. The person would not die. They would migrate. Their biology would be left behind, but the information that constitutes their mind would persist in a new medium indefinitely. This idea has been taken seriously enough to attract significant intellectual and financial attention. Google has funded related research directions. Ray Kurzweil, who spent years as Google's director of engineering after a long career as a futurist and inventor, has written extensively about it and has publicly stated his intention to pursue it. The philosopher Nick Bostrom has analysed its implications at length. The argument, at its most basic, is simple. If consciousness is information processing, and if we can capture the information, then running the information on new hardware is not death, it is survival. The no-cloning theorem does not make this technologically impossible in any obvious way, and I want to be honest about that, because oversimplification in either direction does not serve us here. The brain is a warm, wet, noisy biological system where quantum coherence, the fragile, precisely maintained quantum state behavior that the no-cloning theorem strictly applies to, is not obviously the central feature of computation. Your neurons fire classical action potentials, electrochemical pulses that propagate down axons and trigger neurotransmitter release at synapses. Your synaptic weights, the strengths of the connections between neurons that encode your memories and personality, are classical quantities, concentrations of receptor proteins, physical structures that exist at scales where quantum effects are not obviously dominant. If consciousness is purely classical computation running on classical hardware, then the no-cloning theorem's strictest implications might not apply, because classical information can, in principle, be copied. This is what computers do every time they save a file. So the no-cloning theorem does not immediately kill the uploading proposal. But here is where the problem deepens in a way that is independent of quantum mechanics entirely. Even setting quantum mechanics completely aside, even granting, for the sake of argument, that consciousness is entirely classical and that the brain's quantum states are irrelevant to experience, the copying problem does not go away. It just changes form. And the form it takes is one of the most philosophically destabilizing questions you can ask about personal identity. The continuity problem. Imagine that the technology exists. Imagine that tomorrow you walk into a facility, lie down in a scanner of extraordinary precision, and allow your complete brain state to be mapped in full detail. Every neuron, every synapse, every connection weight, the entire structural and functional architecture of your mind, captured with perfect fidelity at the moment of scanning. That information is then loaded onto a computational substrate and initialized. The simulation begins running from your brain state. It opens its eyes, metaphorically speaking, and immediately reports feeling exactly like you. It has your memories, it has your personality, it has your sense of humor, and your fears, and your preferences, and your relationships, and your sense of continuity with the person who walked into the scanner. From the inside, the simulation reports an unbroken stream of conscious experience, from your childhood to this moment to right now. Meanwhile, you, the biological original, are still lying on the scanner table. Your brain is still running. Your neurons are still firing. You are still having experiences, moment by moment, that the simulation is not sharing because the simulation initialized from a snapshot and has been diverging from your biological state since the moment it was created. You received a sensory input that the simulation did not receive. You thought a thought that the simulation did not think. 1 second after initialization, you and the simulation are no longer identical. After 1 minute, you are measurably different. After 1 hour, you are having noticeably different experiences, building noticeably different memories, developing in noticeably different directions. Now the facility asks you to authorize the destruction of your biological brain, the original, because maintaining both indefinitely was never part of the plan and the simulation is running fine, and isn't that the whole point? Here is the question. If you authorize that destruction, do you survive? The simulation survives. The simulation will wake up the next morning with your memories and tell everyone that it is you and feel, from the inside, with complete subjective certainty that it is you. And it will be wrong, in a specific and important way. Not because it is less than you, not because it is a lesser entity, but because there was a gap, a moment of termination of the original biological process. And the experiential continuity that most people mean when they say, "I want to survive death," runs through the original process, not through the copy. The copy's continuity began at initialization. Yours ended at destruction. These are different continuities, even if they are phenomenologically indistinguishable from the inside. This is not a semantic distinction, though it is often dismissed as one. It is the same problem that arises when you think carefully about the science fiction transporter, the device that disassembles you at one location, transmits the information, and reconstructs you at another. The person who steps out of the transporter at the destination has your memories and your face and your personality, and will swear on everything they hold dear that they are you, but you were disassembled. The process that was running, the continuous, unbroken thermodynamic and informational process that we have been calling you throughout this entire video, was terminated. A new process was initialized from a description of the old one. That is not survival in the sense that actually matters to anyone asking the question. It is replacement. Replacement so perfect that it cannot be detected from the outside or even from the inside of the replacement. But replacement nonetheless. And here is the thing. The universe does not care about this distinction. The universe does not track whether a process is continuous or has been interrupted and restarted from a checkpoint. The physics does not contain a variable for experiential continuity. The laws of nature operate the same way, regardless of whether the pattern running on a substrate has been running continuously since birth or was initialized from a save state this morning. The distinction matters only to the person asking whether they personally survive, and it matters enormously to them. It is, arguably, the only thing that actually matters to them about the question of death. Physics can tell you that no mechanism of continuity bridges the gap between the original and the copy. It can tell you that quantum teleportation of your brain state, if it were possible, would destroy the original in the process of transmitting the information. It can tell you that any copying process that is not teleportation will produce a copy while the original continues to exist as a separate, immediately diverging entity, which means what you have created is not survival but a twin. And it can tell you that what most people mean by survival, the continuation of an unbroken thread of experience from now into the future, cannot be delivered by any copying process, classical or quantum, because copying creates two things from one, and you are only one of them. The no-cloning theorem adds a further layer to all of this for any scenario in which quantum effects in the brain are relevant to consciousness, a possibility we will examine in more depth in the next section. If consciousness has any quantum component, if the specific quantum states of the molecules and fields inside your neurons contribute to the character or content of your experience in any way, then the no-cloning theorem means that not only can you not preserve the classical information of your brain state without losing the quantum information, but any attempt to capture the quantum state in sufficient detail to copy it will inevitably disturb and alter it. The measurement required for the copy changes the original. You cannot read out a quantum state without writing into it. And therefore the copy, however faithful, is a copy of something that no longer quite exists in the form it existed before the copying process began. Your quantum brain state is, in the most rigorous physical sense available, unique and irreplaceable, not as a sentiment, not as a comforting story, as a mathematical fact enforced by the structure of quantum mechanics. It cannot be duplicated. It can be transmitted, but transmission means the original is gone. It can be destroyed, and then it is gone. It cannot be held, preserved, copied, backed up, or maintained in parallel with a duplicate of itself. There is exactly one of you. There has always been exactly one of you. There will only ever have been exactly one of you. This is not poetry, it is physics. Combined with the no-hiding theorem from the previous section, this creates a portrait of the self that is genuinely strange and genuinely new, something that neither traditional religion nor simple materialism quite anticipated. You are unique and unrepeatable, enforced by quantum mechanics. Your information is conserved but dispersed into an expanding light cone, guaranteed by the no-hiding theorem. And the combination of uniqueness and dispersal means that what you are cannot be reconstituted from what you leave behind. The specific physical configuration that is you, the extraordinarily precise quantum state of the pattern running in your brain right now, will never exist again, in any form, at any time, anywhere in the universe. Not because the universe destroys it, but because the universe scatters it, and the no-cloning theorem ensures there was never a backup, and the light cone ensures the scattered pieces can never be reassembled. This is not nihilism. I want to be clear about that. It is precision, and there is a difference, even though precision about certain things can feel like nihilism until you sit with it long enough to notice that it is actually something else, something more honest. But before we get to what that something else might be, there is one more layer to add to this picture, and it comes not from physics, but from philosophy and cognitive science, from people who have been asking the question of where the self lives from a completely different direction and arriving, remarkably, at the same place. The Scottish philosopher David Hume, writing in the 18th century, did something that was unusual for a philosopher of his era. Instead of building elaborate metaphysical systems about the nature of the soul from first principles, he turned his attention inward to to the direct evidence of his own conscious experience and tried to actually locate the self, not to reason about where it should be, but to observe where it is. And what he found, or rather, what he conspicuously failed to find, was both honest and, in its way, devastating to a great deal of what philosophy before him had assumed. He could never catch himself without a perception. Whenever he looked inward, there was always something, a thought, a feeling, a sensation, a memory, an impression of one kind or another. But he never found, underneath or behind or prior to those perceptions, a separate observer. No underlying witness, no ghost in the machine watching the show. Just the show, an endless stream of perceptions flowing through consciousness, with no perceiver that was separable from the perceptions themselves. He concluded from this that the self is not a substance, not a thing that exists independently and has experiences, but a bundle, a collection of experiences that the mind narratively stitches together into the appearance of a unified observer, a continuous self, an entity with identity persisting through time. The self, for Hume, is a story we tell about the stream. It is not the stream, and it is not a teller, it is the telling. This is a remarkable conclusion to reach in the 18th century through pure introspection, because it anticipates, with striking accuracy, what cognitive neuroscience and computational theories of mind would arrive at more than 2 centuries later through completely different methods. Daniel Dennett, the philosopher and cognitive scientist who has spent his career trying to give a rigorous account of consciousness that does not require invoking anything outside normal physical and computational processes, built a model of consciousness that is, at its heart, Humean. His multiple drafts model, developed and refined through works including Consciousness Explained, published in 1991, and refined in subsequent decades, holds that consciousness is not a process occurring in a single, specific location in the brain, the way a film is shown in a specific theatre to a specific audience. There is no Cartesian theatre. There is no place in your brain where everything comes together for a final presentation to the self. There is no moment of unification where all the parallel processing streams of the brain converge into a single, privileged output that is then experienced by a central observer. What there is, instead, is distributed processing, parallel, simultaneous, competing narrative drafts running across the brain, each representing a different version or interpretation or moment of the ongoing experience, none of them privileged over the others in any architecturally special way. What we call conscious experience, the sense of a unified stream of awareness moving through time, is the output of all those drafts interacting with each other, the brain's best attempt to construct a coherent narrative from its own distributed processing. And the sense of a unified self, the feeling that there is a you who is having these experiences, a continuous observer moving through time, is not a discovery about what the brain contains. It is a construction. It is the brain's model of itself, generated by the same machinery that generates everything else the brain models, and no more fundamental than any other model the brain runs. If Dennett is right, and the neuroscientific evidence for distributed parallel processing as the substrate of consciousness is substantial and growing, then the self was never a substance in the first place. It was always a process, a continuously constructed narrative, a running story the brain was telling about itself and its relationship to the world, updated moment by moment with new input, revised and reconstructed and maintained in the telling. The self is not stored anywhere in the brain. It is not encoded in any particular structure. It is the ongoing activity of generating the story, and the story is inseparable from the telling. Stop the telling, and the story does not continue somewhere else. Stop the telling, and the story ends. Because the story was the telling, it was always only the telling. When the brain stops, when the metabolic processes maintaining the electrochemical activity that generates the narrative run down, the self does not depart. It does not migrate. It does not go anywhere, because it was never the kind of thing that exists separately from the process that generates it. It was the process, and processes, when they stop, do not go somewhere. They stop. This is the collapse of the classical soul model, and it is worth being clear about the fact that it does not come from physics alone. It comes from convergence, from physics and neuroscience and philosophy approaching the same question from completely different directions and arriving with remarkable consistency at the same answer. No separable soul, no essence that persists independently of the physical substrate, no storage location in any corner of the brain or the universe where you are kept between the moments of your life. Only dynamic system behavior, generating the appearance of a unified self for as long as the system is running, and then not. The process ends. The pattern disperses into the universe that made it. And the narrative, which was never a thing, only an activity, simply stops mid-sentence. But here is where I want you to pause and really hold on to what comes next, because we are about to move into the final part of this journey, and it is the part that surprised me the most when I spent time thinking it through carefully, because physics does not simply take the soul away and leave nothing. That would be too simple. That would be the clean, neat, switch off the light answer. What physics actually does is stranger than that. It takes the soul away in the form we imagined it, the traveling entity, the persistent observer, the continuous stream of experience that survives the body, and it replaces it with something that nobody was quite expecting, something that comes from the geometry of space-time itself, something that has to do not with what happens after you die, but with the physical status of every moment you were alive. Whether those moments persist in any meaningful physical sense after they are over. And the answer that physics gives, rigorous, defended, taken seriously by some of the most careful thinkers in theoretical physics, is yes. Every moment of your life still exists, not as a memory, not as a trace, not as a record preserved somewhere, as an actual, geometrically real region of the four-dimensional structure of space-time, as permanent and as real as any other region of the universe. Your childhood still exists. The moments that made you are still there, and so is the moment of your death, and so is every moment in between. That fact is, simultaneously, the most profound comfort and the most unsettling horror that physics has ever offered to a conscious being thinking carefully about their own existence. And it is where we are going next. Part 5. The unsettling replacement. There is a view of the universe that has been the quiet working assumption of most physicists for roughly a century. It is not fringe. It is not speculative in the way that string theory is speculative, or in the way that the multiverse is speculative. It is the picture of reality that falls directly out of the geometry of space-time that Einstein's special and general relativity describe, and it is supported by everything we know about how the physical world actually behaves at the deepest levels we have been able to probe. Most physicists accept it, at least implicitly, as the most natural reading of the mathematics, and yet its implications are so strange, so genuinely destabilizing to ordinary human intuitions about time and existence and what it means to be alive, that even most physicists do not spend much time thinking about them. Not because the implications are wrong, because they are uncomfortable in a way that does not cash out into better experiments or cleaner equations, and physicists, being human, tend to focus on the parts of their work that lead somewhere practically useful. The view is called the block universe, and the name describes it with unusual precision. The universe, in this framework, is not a three-dimensional space that exists at a moment called now, and changes as time passes, and leaves a past behind it that no longer exists, and approaches a future ahead of it that does not yet exist. That picture, the picture of a universe that flows, that has a present moment moving through time like a bead on a wire, is, according to the block universe interpretation, a cognitive illusion, a feature of how conscious beings embedded in time experience reality, not a feature of reality itself. The universe is not a process, it is a structure, a four-dimensional structure, 3 dimensions of space and 1 dimension of time that exists, all of it, simultaneously as a complete and unified whole. Past, present, and future are not stages of a process. They are locations within the structure. They are all equally real, all equally there, all equally existent, in the same way that London and Tokyo are both real, even though you are currently in one and not the other. Your current location does not make Tokyo less real. Your current moment does not make last Tuesday less real, or the moment of your death less real. They are all just coordinates in the four-dimensional geometry. The idea comes directly from Einstein. In special relativity, the separation between 2 events in spacetime is not simply a spatial distance or a temporal duration, but a combination of the two, a quantity called the spacetime interval, which is the same for all observers regardless of their relative velocities. Space and time are not independent. They are woven together into a single 4-dimensional fabric, and the way different observers perceive them depends on how they are moving relative to each other. 2 observers moving at different velocities through spacetime will measure different distances between the same pair of events and different durations between them. Their rulers and their clocks will disagree, but they will agree on the spacetime interval, because the spacetime interval is the invariant quantity, the real geometric relationship between events, independent of any particular observer's perspective. One of the consequences of this geometry is something called the relativity of simultaneity. 2 events that are simultaneous for one observer that happen at the same moment according to their clock may not be simultaneous for another observer moving at a different velocity. The question of whether 2 distant events happen at the same time has no absolute answer. It depends on who is asking and how fast they are moving. This is not a measurement problem. It is not an artifact of signal travel times that careful analysis can correct for. It is a genuine feature of the geometry of spacetime. Simultaneity is relative, not absolute. And this has an immediate and profound implication for the concept of now. If 2 observers moving at different velocities disagree about which events are simultaneous, then there is no single, universal now that is the same for all observers. There is no absolute boundary that cleanly separates what has already happened from what is still happening or what has not yet happened. The boundary depends on who is drawing it. Different observers, moving at different velocities relative to each other, will disagree about which events are in the past, which are in the present, and which are in the future, not for events in their immediate vicinity, where the disagreements are negligibly small, but for distant events where the disagreements can be substantial. The cosmologist Sean Carroll, who has written and spoken about the block universe with more clarity and accessibility than almost anyone else working in theoretical physics, offers an analogy that is worth holding on to. The word now, he points out, functions in time the way the word here functions in space. When you say, "I am here," you are pointing to your current location, a specific set of spatial coordinates that has no special status in the universe's physics. The laws of nature do not distinguish your current location from any other location. Sydney is not less real because you are not currently in Sydney. It exists with full physical reality at its own set of coordinates. Your being somewhere else does not demote it in the hierarchy of existence. It is simply elsewhere. And Carroll's point is that the same logic applies to time. When you say, "it is now," you are pointing to your current temporal coordinate, a specific moment that has no special status in the universe's physics. The moment of last Tuesday is not less real because you are not currently in it. It exists with full physical reality at its own set of temporal coordinates. You are simply elsewhere in time, the way you might be elsewhere in space. The past has not been deleted. It is just not where you currently are. Take a moment with that. Really take a moment, because this is the kind of claim that sounds like philosophy but is actually physics, and the distinction matters. This is not a metaphor or a way of speaking designed to make you feel better about the passage of time. This is the most natural reading of a physical theory, special relativity, that has been experimentally verified to extraordinary precision in thousands of experiments over more than a century. When physicists say the block universe is supported by everything we know about relativity, they mean it. The mathematics does not just permit this interpretation. For many physicists, it demands it, or something very close to it. Now apply this to a human life. Every moment of your childhood still exists, permanently, not as a memory, not as a psychological trace, not as a record preserved in the neurons of the people who were there, as an actual, geometrically real region of four-dimensional spacetime, as fully real as the moment you are currently experiencing. The afternoon when you were 8 years old and something happened that you have never forgotten, that afternoon still exists, at its coordinates in the four-dimensional structure. The specific configuration of matter and energy and information that constituted you and your surroundings in that moment is still there, embedded in the geometry of spacetime, as real and as permanent as any other region of the universe, not preserved, not archived. Simply real, the way all locations in the structure are real, because the structure contains them and the structure does not have a deletion mechanism. Every relationship you have had, every decision you have made, including the ones you regret and cannot undo, every ordinary Tuesday afternoon that felt unremarkable while you were in it, the kind of afternoon you could not possibly remember even if you wanted to, every moment of boredom and every moment of joy and every moment of confusion and every moment in which you understood something that you had not understood before, all of it is there. All of it is geometrically real. All of it exists in the block universe with exactly the same ontological status as right now, including the moment of your death. That moment is also there in the four-dimensional structure. It is a specific set of space-time coordinates, like every other set of space-time coordinates. It is real, it is permanent, and it is no more or less existent than the moment you were born or the moment you are currently experiencing. From the perspective of the block universe, death is not the end of you in the sense of an erasure. It is a boundary within your world line, the four-dimensional path that you trace through space-time from the moment of your birth to the moment of your death, a line in four-dimensional space connecting two sets of coordinates. The world line exists completely and permanently, all of it, from one end to the other, including the end. You are not deleted at death, you are bounded. Now here is where the comfort and the horror arrive simultaneously. And I want to be careful to present both honestly, because it would be easy to lean into one and minimize the other, and the full weight of what the block universe means requires holding them both at the same time. The comfort first. The block universe tells you that you will always have existed. That is not a sentiment, that is a physical statement. The region of space-time that contains you, that contains every moment of your life, from the first to the last, is a permanent feature of the universe's geometry. It cannot be removed. It cannot be overwritten. It cannot be erased by time passing, because time passing is itself just movement through the four-dimensional structure, and movement through the structure does not delete the regions you have moved through. You cannot unhappen. Nothing that has ever happened can unhappen, because the block universe does not contain a mechanism for unhappening. Every event is permanent. Every moment is eternal, in the specific sense that eternity means. Not that it goes on forever, but that it is not subject to deletion. If your primary fear about death is the fear of being forgotten, the fear that after you are gone, the world will eventually proceed as though you were never here, that the mark you left will fade, that the people who knew you will die too, and then there will be no one left who carries any trace of you, then the block universe has something genuinely meaningful to offer, not comforting in a soft, reassuring way, comforting in a cold, precise, physically rigorous way. You cannot be forgotten by the universe, because the universe does not have memory, it has geometry, and geometry does not forget. You are there, in the four-dimensional structure, for as long as the structure exists, which, on our best current understanding of cosmology, means for a time so vast it makes the current age of the universe look like the blink of an eye. The region of space-time where you loved someone still exists. The region where you figured something out for the first time still exists. The region where you were a child still exists. These are not metaphors. They are coordinates. They are real. And now, the horror. The block universe does not provide experiential continuity across those moments. Let me be precise about what I mean, because this is the exact point where the comfort runs out and the strangeness sets in. When you imagine some form of afterlife, when you imagine the soul persisting after death in any form that you would find meaningful, what you are imagining is continuation, an ongoing stream of experience. A consciousness that moves forward through time, past the point where the body gives out, that continues to experience, to perceive, to be. The thing that makes survival feel like survival, rather than just preservation, is the continuity of the experiential stream. You want there to be a perspective that persists, a what it is like to be you that continues being like something after the biological substrate fails. The block universe does not give you that, not even approximately. The block universe tells you that the region of space-time where you were 8 years old is permanently real, but it does not tell you that the 8-year-old version of you is currently experiencing anything. That version of you, at its specific space-time coordinates, experienced what it experienced when it was there. The experience was real, it was genuine, it was fully present and fully alive in the moment it occurred. But the block universe does not contain a mechanism by which a region of space-time that is not your current location continues to experience, any more than Tokyo continues to exist from your first-person perspective while you are in London. The existence and the experience are decoupled. The moment existed. The experience was in the moment. The moment is permanent. But the experience is not ongoing. It is contained within the moment, as it always was, and the moment simply is, without experiencing anything from outside itself. The 8-year-old version of you exists permanently in the block universe. But it is not having an experience right now in the sense of a currently running subjective process. It exists the way a photograph exists, permanently capturing a real moment, genuinely representing something that happened, not in any sense experiencing its own existence or aware of its own permanence. The permanence is real, the experience was real, but the permanence and the experience do not combine into ongoing consciousness. They combine into something that is harder to name, permanent existence without ongoing experience, which is not the same as any kind of afterlife that anyone has ever prayed for. This means the block universe offers a specific and strange package, and I want to be honest about its contents. You existed completely and permanently, for every moment between your birth and your death, embedded forever in the structure of space-time. And then, at the final coordinates, at the boundary of your world line, the process ended. And the end is also permanent, also real, also part of the four-dimensional structure. The boundary exists as surely as everything inside it. You always will have been, and you always will have ceased. Both of these things are simultaneously, permanently, equally true. The existence and the cessation are both eternal features of the geometry. Most people, when they first properly encounter the block universe and sit with its full implications, find themselves somewhere on a spectrum between genuinely consoled and genuinely terrified, and exactly where they land depends almost entirely on what they were most afraid of to begin with. I have talked to people who found it deeply comforting, who felt that the permanence of the past, rigorously established by physics rather than wishfully asserted by hope, gave their lives and the lives of everyone they had loved a weight and a reality that no amount of passing time could erode. And I have talked to people for whom the block universe made everything worse, because it added geometrical precision to the fact of cessation, because it meant that the boundary at the end of their world line was not a fading but a wall, a hard and permanent edge encoded in the structure of space-time, beyond which the experiential process simply does not extend, and the structure simply continues without them in it. Both responses are honest. Both responses are tracking something real about what the block universe implies. Physics does not tell you which one is correct, because the question of whether permanence without ongoing experience is enough to constitute any kind of meaningful persistence is not a physics question. It is a question about what you value, about what you mean when you say you want to survive, about what would actually count as comfort if you could examine your own intuitions precisely enough to know. Physics hands you the structure. What you make of the structure is yours. Now, with all of that in place, with the block universe sitting in the room as the strange and precise thing it is, we need to address the elephant that has been quietly present throughout this entire conversation. Everything we have said so far has been proceeding on an implicit assumption that deserves to be made explicit and then examined, because it turns out to be much shakier than it looks. The assumption is that we understand consciousness well enough to reason clearly about its end. That when we talk about experience ceasing, about the subjective stream terminating, about what it is like to be you, coming to a stop, we are talking about something whose nature we sufficiently understand to make confident claims about when it begins, when it ends, and what physical processes produce it. We do not understand it. Not nearly as well as confident talk about brain states and neural correlates and information processing implies. And the gap in our understanding is not a small one, not a matter of filling in a few missing details. It is, arguably, the deepest unsolved problem in all of science and philosophy combined. It has a name. The philosopher David Chalmers gave it the name in 1995 in a paper that reframed the entire debate about the mind in a way that has not been resolved in the 3 decades since. He called it the hard problem of consciousness. Chalmers drew a careful and important distinction between 2 categories of questions about the mind. On one side, there are what he called the easy problems, not easy in the sense of being simple to solve, but easy in the sense that we know, at least in outline, what a solution would look like, and what kind of scientific investigation would lead us there. The easy problems include explaining how the brain integrates information from different sensory modalities into a unified percept, how it directs attention towards certain stimuli and away from others, how it generates reports about its own internal states, how it controls voluntary behavior, how it distinguishes waking from sleep. These are genuinely hard scientific questions that occupy entire research programs and are nowhere near fully answered. But they are tractable in principle because they are questions about function, about what the brain does, how it processes information, how its mechanisms work. And questions about function can, in principle, be answered by the standard methods of neuroscience, mapping neural circuits, identifying molecular mechanisms, building computational models, testing predictions against experimental data. On the other side, there is the hard problem. And the hard problem is not about function at all. The hard problem is this: why is any of this processing accompanied by subjective experience? Why does it feel like something to see the color red, rather than just involving the processing of wavelength information in a way that produces appropriate behavioral responses with no inner experience attached? Why is there a what it is like to be you at all, rather than just an information processing system running in the dark, with no one home, no inner light, no experience of anything? You could, in principle, imagine a being physically identical to you in every functional respect, the same neural architecture, the same behavior, the same responses to stimuli, the same verbal reports about inner experience, but with no subjective experience whatsoever. A philosophical zombie, in the language of the debate, that processes and responds and reports, but does not feel. The question the hard problem asks is, what is the difference between you and the zombie? What physical fact about you accounts for the presence of experience when the functional description is identical? Nobody knows. That is the honest answer, and it has remained the honest answer despite 30 years of sophisticated philosophical argument and significant advances in neuroscience since Chalmers named the problem. The gap between the objective, third-person description of neural activity and the subjective, first-person experience of being the thing having that activity has not been bridged. Proposals for how to bridge it are numerous and various. Materialism, the dominant position in philosophy of mind and neuroscience, holds that the bridge is there and we just have not found it yet, that consciousness is entirely a product of physical processes in the brain, and the apparent explanatory gap will eventually close as our understanding deepens. Dualism holds that the gap cannot be closed because consciousness is not physical in the way the brain is physical, that mental events are a distinct category of reality that is not fully reducible to neural events. Panpsychism, which has experienced a remarkable revival in serious philosophical circles over the last 2 decades, holds that consciousness is not something that emerges from complex physical systems, but is a fundamental feature of reality that goes all the way down to the basic constituents of matter, and that what the brain does is organize and integrate pre-existing consciousness rather than create it from non-conscious components. Illusionism, associated particularly with the philosopher Keith Frankish, holds that the subjective experience itself, the felt quality of consciousness, is in some sense a cognitive construction, that the explanatory gap feels insurmountable because we are systematically deceived about the nature of our own inner experience in ways that make a purely functional explanation seem insufficient when it is actually complete. None of these positions has achieved consensus. All of them have serious defenders and serious critics. The debate is as active and unresolved today as it was when Chalmers named the problem, and in some ways more so. There are more positions on the table, more experimental results that need to be accommodated, and a growing recognition that the question may be harder than even Chalmers originally suggested. Some philosophers have argued, with genuine seriousness, that the hard problem may be permanently unsolvable by human minds, that we may simply lack the cognitive architecture necessary to understand how physical processes give rise to subjective experience, in the same way that a dog lacks the cognitive architecture to understand calculus, not because the answer does not exist, but because the kind of understanding required may be outside the reach of the kind of mind we happen to be. Why does this matter here? Because the uncertainty about what consciousness is directly and inescapably related to our uncertainty about what happens to it at death. Everything we have said in this video, the no-hiding theorem, the light cone dispersal, the no-cloning theorem, the block universe, has been built on a picture in which consciousness is the functional activity of the brain, the integrated process we described in part 2, the narrative the brain generates about itself and its world. If that picture is complete, if consciousness is exactly and entirely what it looks like from the functional description, then it ends when the function ends, and the physics we have traced tells us where the information goes and why the pattern cannot be reconstituted. The story is complete, if cold. But if consciousness has a physical character that our current theories do not capture, if there is something about subjective experience that requires an account that goes beyond the functional description, something that the hard problem is tracking and that science has not yet found a way to address, then our picture of what ends at death is incomplete in ways we cannot currently characterize. And that is where the most contested, most debated, most scientifically embattled idea in this entire conversation enters the picture. I want to be clear about its status before we go further, because honesty requires it. What follows is not accepted mainstream science. It is not the consensus view of neuroscientists or physicists. It is a hypothesis, contested, criticized, and, for many in the field, effectively refuted, though its proponents vigorously dispute that characterization. We are discussing it not because it is probably right, but because it represents the most serious scientific attempt to argue that consciousness involves physical processes that go beyond classical computation, and because understanding why it was proposed and what has happened to it since illuminates the central question of this video in ways that nothing else quite does. The idea is called orchestrated objective reduction, ORCH, OR for short, and it was proposed by two people who approached the question of consciousness from completely different directions and found themselves, improbably, converging on the same strange territory. Roger Penrose is a mathematical physicist, one of the most mathematically gifted scientists of the 20th century. The man who proved fundamental results in general relativity alongside Stephen Hawking, who won the Nobel Prize in Physics in 2020 for his work on black holes, and who has spent decades developing an argument about human consciousness that most of his colleagues in physics regard with a mixture of respect for the source and deep skepticism about the conclusion. The argument is laid out in two books, The Emperor's New Mind, published in 1989, and Shadows of the Mind, published in 1994, and at its heart, it makes a claim about the limits of computation. Penrose's starting point is Gödel's incompleteness theorems, published by the Austrian mathematician Kurt Gödel in 1931. Gödel proved that any formal mathematical system powerful enough to describe basic arithmetic will necessarily contain true statements that cannot be proven within the system. You cannot build a complete and consistent formal system that proves all the mathematical truths expressible in it. There will always be truths that are true but unprovable, statements that a human mathematician can recognize as true by seeing outside the system, but that no algorithm operating within the system can ever reach. Penrose's argument is that human mathematical understanding is not algorithmic. When a mathematician sees that a Gödelian statement is true, when they grasp a mathematical truth that no proof procedure could produce, they are doing something that no Turing machine can do. And since any computational system is equivalent to a Turing machine, consciousness cannot be entirely a matter of classical computation. Something in the physics of the brain must be implementing a non-computational process. Penrose spent years looking for a candidate. He found one in quantum gravity. The candidate is this. Quantum mechanics tells us that physical systems can exist in superpositions, states that are simultaneously multiple possibilities at once, in a mathematically precise sense, until something causes the superposition to resolve into a single definite outcome. What causes this resolution, what physicists call the collapse of the wave function, is one of the deepest and most unresolved questions in the foundations of quantum mechanics. The standard answer, or at least the most widely used working assumption, is that the superposition resolves when the quantum system interacts with the environment and becomes entangled with it in a process called decoherence. But Penrose proposed a different mechanism. He proposed that superpositions at the level of space-time geometry, quantum superpositions in which the very fabric of space and time is in multiple configurations simultaneously, are inherently unstable and that they resolve spontaneously, not due to environmental interaction but due to a fundamental principle of quantum gravity. When the difference between the superposed geometries reaches a threshold related to the Planck scale, the scale at which quantum effects and gravitational effects become comparably important. This spontaneous resolution, which Penrose calls objective reduction, emphasizing that it is not caused by any observer or measurement, but is an objective physical process, is, he argues, non-computational. It is not the outcome of any algorithm. It is a physical event at the boundary between quantum mechanics and general relativity, at the deepest level of physical reality we can currently conceive of, and it happens in a way that is not determined by any computational process. And this, Penrose suggests, is where consciousness lives. The elementary acts of consciousness are objective reductions. Experience is what it is like from the inside when space-time geometry resolves a quantum superposition. Stuart Hameroff is an anesthesiologist at the University of Arizona who had been studying microtubules, the protein scaffolding structures inside cells that maintain cellular architecture and serve as highways for molecular transport, for years before he encountered Penrose's work. Hameroff had noticed that microtubules have a crystalline lattice structure that, at least in principle, could support the kind of ordered quantum processing that Penrose's theory required. He proposed that microtubules inside neurons are the biological substrate where objective reductions occur, that quantum superpositions are maintained in the protein lattice of microtubules for biologically relevant timescales, that these superpositions are orchestrated, shaped and organized by the cellular machinery around them, and that the objective reductions of these orchestrated superpositions are the physical basis of conscious experience. Orchestrated because the biology shapes which superpositions form. Objective reduction because Penrose's mechanism resolves them. OR. The theory was greeted with interest and with immediate, serious objections. The most devastating came in 2000 from the physicist Max Tegmark, who published a calculation showing that the thermal noise environment inside a neuron, the warm, wet, constantly fluctuating biochemical milieu, would destroy any quantum coherence in microtubules in approximately 100 femtoseconds. A femtosecond is 10 to the power of minus 15 seconds. 100 of them is 10 to the power of minus 13 seconds. This is an unimaginably short time, orders of magnitude shorter than any neural process, shorter than the fastest synaptic event, far too brief for any quantum computation relevant to cognition to occur. Tegmark's calculation, if correct, did not just make OR unlikely, it made it physically impossible on the timescales required. The theory was widely regarded as dead. And then something unexpected happened, slowly, over the following 2 decades. Experimental evidence began accumulating from entirely different directions and motivated by entirely different questions, that quantum coherence in biological systems persists for much longer than decoherence calculations like Tegmark's predicted. In 2007, a paper in Nature reported evidence for quantum coherence in the photosynthetic light harvesting complexes of green sulfur bacteria, the molecular machinery that captures photons and funnels their energy toward the reaction center where photosynthesis occurs, lasting for hundreds of femtoseconds, possibly longer, in conditions that were warm and noisy by quantum standards. Subsequent work extended these findings to other photosynthetic organisms and began suggesting that the coherence might not just be surviving in the biological environment, but being actively exploited, that the biological machinery had evolved to use quantum effects in the service of efficient energy transfer in ways that would not be predicted or even accessible to classical physics. Quantum effects were found to be relevant in enzyme catalysis, where the ability of protons to tunnel through energy barriers, a quantum mechanical phenomenon, appears to be exploited by enzymes to achieve reaction rates that classical mechanics cannot account for. They were found in the avian magnetic compass, where migratory birds apparently use quantum entanglement between electron spin states in cryptochrome proteins to detect the direction of the Earth's magnetic field, with a sensitivity that requires quantum mechanics to explain. They were found in the molecular mechanism of olfaction, where the quantum mechanical process of electron tunneling may contribute to the ability to distinguish molecules that are identical in shape but different in their vibrational frequencies. Biology, it was becoming clear, is not the quantum inert environment that had been assumed. Life had been doing quantum things for billions of years, quietly, in the warm, wet interior of cells, in ways that physicists had assumed were impossible. None of this proves or. The gap between quantum coherence occurs in some biological molecules for hundreds of femtoseconds, and quantum superpositions in microtubules are the physical basis of conscious experience is enormous. More recent experimental work, specifically on microtubules, including work by the physicist and neuroscientist Anirban Bandyopadhyay and his group, who have published intriguing results about the electrical signal processing properties of microtubule lattices, and work by others measuring the quantum properties of tubulin, the protein subunit from which microtubules are built, has found results that Hameroff and Penrose have pointed to as suggestive support, while critics have argued that the results, while interesting, fall well short of establishing the quantum coherence on the timescales and spatial scales that Ochoa requires. The theory remains contested. Its most fundamental pillar, Penrose's argument about the non-computational nature of human mathematical understanding, continues to be challenged by philosophers of mathematics and cognitive scientists who argue that the argument from Gödel's theorems does not actually establish what Penrose claims it establishes. The theory is alive. It is not well, but it has not died the clean death that Tegmark's 2-1000 paper seemed to promise it. And what would it mean, for the question we have been asking, if some version of or were true? Here is where I want to be careful, because this is the point at which the temptation to reach for comfort is strongest, and the point at which that reach would be most misleading. If consciousness involves objective reductions in the quantum gravity regime, if experience is, in some sense, the universe organizing itself at the boundary between quantum mechanics and space-time, then consciousness is more deeply physical than the standard neuroscience picture suggests, not less physical, more. It is woven into the fundamental structure of space-time, not merely an emergent property of complex neural computation. It is, in the or picture, something the universe does at its most basic level, not something the brain invented by getting complex enough. That sounds, at first glance, like it might open a door, like it might provide some mechanism by which consciousness persists beyond the failure of the biological substrate, like it might be the physics version of the soul. It is not. And here is why. Even in the most generous possible interpretation of or, the objective reductions that constitute consciousness are orchestrated. That is the first word in the name, and it matters. The biological context, the specific architecture of the microtubules, the cellular machinery that shapes which quantum superpositions form, the neural network within which the microtubules are embedded, is what makes the reductions into conscious experience rather than random quantum noise. Remove the biological context and you do not get consciousness freed from the body. You get objective reductions occurring in some other physical context, orchestrated by whatever physical environment surrounds them, bearing no relationship to the specific conscious experience that was happening inside the organism. The consciousness that or describes is not a quantum field that persists when its biological host dies. It is a process that requires the host to run. When the host stops, the process stops. When the biological orchestration ceases, the reductions that were producing conscious experience cease to be conscious experience. They become something else, or nothing that we would recognize. What or actually gives you, if true, is not a soul that survives the body. It gives you a consciousness that is more fundamentally physical than we thought, and therefore, if anything, more completely dependent on its physical substrate, not less. The soul does not become free when the body fails. it becomes more thoroughly, more irrevocably terminated, because the physical process that produces it is more specific, more precisely dependent on its biological implementation than a purely classical computational account would suggest. OR does not rescue the traditional soul. It dissolves it at a deeper level. So where does all of this leave us? Let us stand back for a moment and look at the full territory we have covered, because it is worth seeing the shape of it from the outside before we descend into the final reckoning. We started with Debunking McDougall and his scale in 1907 in a hospital room in Haverhill, Massachusetts, waiting for a dying man to lose 21 grams. We found that the experiment was methodologically indefensible. 6 patients, cherry-picked data, uncontrolled variables, published in the wrong journal, inflated into cultural mythology by a story-hungry press and a belief-hungry public. The number was never right. But the question behind it, what does physics say about the soul? What actually happens to the information that constitutes a human being when the biological process ends, turned out to be a genuinely answerable question, just not with a scale. We move from the scale to the body. We found that the body is not the kind of thing that could contain a soul in the way a box contains an object, because the body is not a fixed container. It is a thermodynamic process, a pattern maintaining itself in a continuous flow of matter and energy, with no fixed material substrate, with no permanent atoms or molecules, with the vast majority of its physical components cycling through it and out of it, and being replaced on timescales of months to years. The atoms are visitors. What persists is the pattern. You are not a thing that has stayed the same while its parts changed. You are the changing itself, organized into a coherent form by the continuous expenditure of metabolic energy, and nothing about you is as stable or as contained as the word body implies. We moved from the body to information. We found the no-hiding theorem, the mathematically proven, experimentally verified result that quantum information cannot be destroyed. When the biological process ends and the pattern can no longer maintain itself, the quantum information that constituted the specific physical configuration of your brain disperses into the environment, encoded in quantum correlations with the surrounding physical world. It does not vanish. The no-hiding theorem forbids it. But we found the light cone, the expanding sphere of causally influenced spacetime, growing in all directions at the speed of light, into which that dispersed information is constantly spreading, growing more diffuse, becoming more thoroughly entangled with everything else, until the original pattern is so thoroughly scrambled into the background of the universe that no mechanism could reconstitute it. The information persists. The self does not. Every atom of the ash is conserved, and the book is gone. We moved from information to uniqueness. We found the no-cloning theorem, the proof that an unknown quantum state cannot be copied, that perfect duplication of quantum information is physically impossible, that you are exactly one in a sense enforced by the mathematics of quantum mechanics, rather than merely asserted by sentiment. We examined the proposals for surviving death through mind uploading and found them wanting not at the technological level, but at the philosophical one, the continuity problem, the gap between terminating the original and initializing the copy, the way that survival through duplication requires redefining survival in a way that strips out the part people actually care about. And we found that if quantum effects matter to consciousness, the no-cloning theorem makes the uniqueness even more absolute. Your quantum brain state cannot be copied without being altered in the copying, and cannot be transmitted without being destroyed at the source. We moved from uniqueness to the block universe, the picture of reality in which every moment of your life exists permanently in the four-dimensional structure of space-time, as real and as permanent as any other region of the universe. We found the strange package it offers: permanence without ongoing experience, eternal existence without continued consciousness. the fact that you will always have been paired with the fact that you always will have ceased, both encoded in the geometry of space-time with equal permanence and equal indifference. We found that whether this is comfort or horror depends on what you are most afraid of, and that physics cannot tell you which one you should feel. And we found the hard problem of consciousness, and awe, and the reminder that the picture is not complete, that we do not fully understand what consciousness is, which means we cannot be fully certain about what ends. The frontier is genuinely open. The science is not finished. But everywhere we have looked, in every direction we have approached the question, the same shape has emerged. The information that constituted you is real, and it persists, and it will never again be assembled into the integrated, self-sustaining, uniquely and specifically you process that it was during your life. What does physics leave you with? It leaves you with this: you are a process, not a substance. You are temporary in your integration and permanent in your components. You are unique in the deepest physical sense, enforced by the mathematics of quantum mechanics, unrepeatable not as a wish but as a law. Every moment of your existence is geometrically real, forever, in the block universe, not preserved, not archived, but actually existent, the way all coordinates in space-time are existent, with a permanence that no passage of time can erode, because the passage of time is itself just movement through the structure, not a deletion of what has been moved past. And the experience, the qualia, the consciousness, the feeling of what it is like to be you, the specific subjective character of seeing this sky and remembering that person and understanding this idea for the first time and feeling that loss in that specific way that only you felt it. That experience occurred. It was real. It was as real as anything in the universe, in the only sense the universe has of real, and it is over. The process ends. The pattern disperses. The narrative stops mid-sentence. And the stopping is as permanent as the living, because both are features of the same four-dimensional structure that contains them. Is the something that physics offers really a kindness? The block universe permanence, the information conservation, the mathematical enforcement of your uniqueness, does this add up to comfort? Or does it add up to the most precise and therefore most confronting description of loss that has ever been offered to a conscious being? The honest answer is that it depends entirely on what you were hoping for. If you were hoping for continuation, for an ongoing experiential stream that carries you forward past the final coordinates of your world line, then physics does not give you that. No honest reading of the evidence provides it. The process ends. The stream stops. The lights, to use the blunt metaphor, go out. That is what the data says, as clearly as data says anything. But if you were hoping for meaning, not the meaning that comes from continuation, but the meaning that comes from having actually, genuinely, physically mattered, then physics offers something that is, in its own cold and precise way, remarkable. The moments were real. They are still real, right now, in the block universe, as real as the moment you are currently experiencing. The universe does not delete its history. The causal structure of space-time means that every event you were part of influenced every subsequent event, propagating forward through time and space in ways that touch everything that came after. The specific version of the universe that exists at this moment, with its exact configuration of matter and energy and information and consciousness, was shaped by every event that has ever occurred, including every moment of your life. Not metaphorically, not poetically, causally, physically, thermodynamically. You happened, and the universe is different because you happened, and that difference propagates forward at the speed of light in all directions for as long as the universe continues to exist. Your influence is written into the causal structure of everything that follows you, diminishing with distance and time, but never reaching zero, because causality does not work that way. That is not the soul. It is not the continuation of experience. It is not what any religion promised. and it would be dishonest to pretend that it is. But it is real in the only sense that physics can offer the word, and that sense, it turns out, is the deepest and most uncompromising sense available. Duncan McDougall wanted a number. He wanted 21 grams, specific, measurable, settable, something he could hold up and say, here is the proof. Here is the soul, weighed and confirmed, departing at the moment of death. What physics actually offers is something he was never looking for and probably would not have found comforting. Not a measurement of the soul, but a dissolution of the premise. Not a wait for what leaves, but a thorough account of why the question of leaving was always the wrong question. The self was never a substance that departs. It was always a process that runs. And when it stops, the information that was running it disperses into the universe that made it, permanently embedded in the causal structure of everything that follows, inaccessible and scattered and smeared across a light cone, expanding outward at the speed of light in every direction, forever. You are conserved, but not continued, permanent, but not ongoing, unique and unrepeatable, enforced by quantum mechanics, and every moment of your existence eternally real in the block universe, and the experience they contained is over, in a way that physics describes with complete mathematical precision and absolutely no consolation whatsoever. Sleep well tonight, knowing that every moment you have ever lived is permanently, geometrically, irreversibly real, knowing that you are exactly one, and that the universe's mathematics has enforced it since before you were born, knowing that the universe, which does not host souls in the traditional sense, has been hosting the process that is you, impermanent in its integration, irreplaceable in its specific configuration, unrepeatable in its quantum uniqueness for every moment you have been running, and knowing that when that process ends, whenever it ends, however it ends, it will leave behind a universe that is permanently, causally, physically different because you were in it, not in a way anyone will necessarily notice, not in a way that preserves your experience or continues your narrative or gives you anything you asked for when you asked to survive, but in a way that is real, in the only way that real means anything, in a universe that runs on physics rather than on wishes. That is not nothing. It is, in fact, the most the universe has ever given anything, and it chose to give it to you.